Okay, I've got my assembly file all set here. I've got my ruler constrained. If you don't know how to do that, watch the video that I provided. I also have this offset for my ruler where if it's too close I can move it, or I can move it back and forth, and that's right here. Or if I want, I can suppress that, so I can right click and suppress, and I can just move this. Just depend. It's up to you how you want to do this. Um, So I'm going to start reading this. So I've moved it so my handle is at the lowest point and I have the least displacement. So where the followers drop down the furthest, and this is going to be my first reading. And in your notebooks, you guys should have that chart set up. And so I'd like for you guys to record this in your notebooks and then do it in Excel. And I am checking that it's in the notebook, so you need to have that done. But in the Excel document I put angle of rotation, height of top of follower, radial dimension, and I've started filling these in. I already did the 45, so now I've got 0, so I can read this. I've got, it's just short of 3/4 and just above 5/8, so we'll call that 11/16. So if I go to Excel, I can actually, this is the bottom, so I can put 11 divided by 16, or actually it's going to do November 16th, that's not what we want, but if we do equals, we'll do 11 divided by 16. Okay, let's try that again. Equals 11 divided by 16, and it worked earlier. Let's make sure this is a number. So I should get 0.69. And then over here we'll go back and find the height of our follower. So we need to go up. Move my ruler a little bit closer. So that is 5 and 1, 2, 3, 4, 5, 6, 7/16. So I'll go back to Excel and I'll do equals 5 plus 7 divided by 16, and I should get 5.375. That's interesting because it's the same. So now if I go here, I can go to my angle constraint and put in 45, and when I rotate it, because it's a constant radius, it's going to stay the same. So that's going to be the same. Now when I put in 90, okay, it's still the same. So I can go back here and I can copy this one down to the 90, copy this one down to the 90. Now I'll go to 135. So I'm going to put in, you should just be able to click on this and it'll ask you to input. So put 135. Now it's moved. So I'm going to go ahead and read this. Now the bottom of my follower is at 15/16. So I'll go to Excel. I'll do equals 15 divided by 16. Okay, and then, oh, that's the height of the top. I'm going to put this in the bottom. Now the top, we'll go find that, and it's pretty close. You make the call on this, whether you want to say it's 5 and 5/8 or 16ths, or go to 30 seconds if you want. So that would be 20, 30, it'd be like 21, 30 seconds. So we could do that. So let's do 5 and 21, 30 seconds. So I'll say equals 5 plus 21 divided by 32. Let's be as precise as we can here. We get 5.625. Now go ahead and fill all this out, and then we'll make our scatter plot. Alright, so now we've got everything graphed. Okay, we've gone through 360 degrees of motion. So now we can make our chart that you guys need to include in your final Google slide. So one thing that you might notice is that the difference between all of these, like if you take these and subtract them, they should all be the same. And that's the distance from the center of your axle to the top of your box. And then the displacement is above that. So it's just interesting. Keep that in mind. We're going to copy this or highlight it. I'm going to insert. We're going to choose a scatter plot and one with smooth lines and markers. And let's go ahead and add our axes titles, and we'll call this inches traveled or something along those lines. We'll call this one degrees of rotation, and we'll call this, let's call this distance, or you could call it displacement, but you could call it distance. Let's call it displacement versus rotation, or something like that. Okay, now this is fine. You can snip this, put it into your presentation that you need to show, and then you'll have to use this to solve for your maximum displacement. And the maximum displacement is going to be the difference between, on either one of these, they should be the same. If they're not, you made a mistake. You need to find the smallest one here, so that's going to be our 5.4375, and subtract that from our highest, which is 6.65625. A lot of decimal points there, but that's okay. That is your maximum displacement, so you also need to record that on your project. So this should be your final. Everyone in the group should have all 4 cams on here. And then here, you guys should have your chart filled out with your maximum displacement. I will check these, and then you guys will submit this on the group assignment on Canvas. And then we'll have a little activity that's like the second part, and we'll do that on the next class. Okay, hope this helps.